All right, so good morning. Today we will do this question from thermodynamics. It's an NCERT Exemplar question, 12.6. It is very important that I read this question in front of you so that helps you understand the situation and the keywords that will help you solve this problem. So I am saying if you capture the keywords from this question, you will be able to solve this question. Let's read the question first. All right, so you have three copper blocks of masses M₁, M₂, M₃. The temperatures are T₁, T₂, T₃. T1 is greater than T2 is greater than T3. It is also given to you, which you need to understand, that finally first the blocks are kept separately, right? Mass 1 T1, mass 2 T2, mass 3 at T3. Now they're brought together like this. So they're touching each other now, and after some time the temperature becomes T. Obviously, right? But we will discuss this why and how of this. Read the question very carefully. There is a phrase written in the question. There is no heat lost to the surrounding. That means the heat doesn't flow from these blocks to the surrounding. This is the key thing you need to remember as a key phrase which gives you the hint as to how to solve this problem. Okay. Now all the three blocks are made up of copper. So we don't have to worry about taking different specific heats, right? Now if you look into the basic of calorimetry, right, for a solid copper block, what is the heat exchanged by a metallic block when it changes its temperature by delta T, right? So we are now solving the question, but we will keep in our mind this particular phrase that the system does not lose any heat to the surrounding, right? But let's start up from the basics of calorimetry. Okay, so I talked about how much heat will you lose, right? So if I have to say that the heat lost or gained, if your temperature rises to gain, right, is given by the mass of the block multiplied by specific heat of the block multiplied by delta T. Now delta T can be positive, that is it gained energy and therefore the temperature went up. It can also be that it lost energy, therefore the energy got lost, the temperature reduced. Okay. Now we know that this is the fundamental calorimetry principle. Whenever we see such questions where there is transfer and you know the three blocks, we have, what are we supposed to find? Equilibrium temperature. Now that is another hint to you that finally the system is attaining equilibrium, right? What is equilibrium? If I were to ask you what is equilibrium, equilibrium is a state where actually the flow of energy between the blocks will stop and each block will become of temperature T, right? Now they cannot exchange energy between themselves. Obviously, there is still a dynamic equilibrium, and you can read about dynamic equilibrium, important concept. But because the temperatures are same now, what's going to happen? No more transfer of heat between them. So how do we put this, in your mind? So we know there is no loss of energy. The final temperature is T, and we also know in the back of the mind that calorimetry tells us that the heat exchange is given by ms delta T. We also know this, right? Now, I told you the most important phrase in this is this particular word, right? Which is there is no heat loss to the surrounding. How will you use this? That there is no heat loss to the surrounding. Okay. Now, let's say the heat gained or lost by the block number 1, which is the hottest, right? So this is your hottest block, right? And this is your coldest block, and this is your kind of middleman, right? So it's a middleman sitting between the two hottest and the coldest one. All right, now so assume that the final temperature of all the block becomes T, which is your equilibrium temperature. Everybody, which means what is the heat gained or lost by the block number 1? It will be given by M1 multiplied by S multiplied by T minus T1. Why did I write T minus T1? Because it is always T final minus T initial. Now for all you know, the T, this T may be less than T1, right? That is the hottest one, so its temperature will drop. So this quantity is going to be negative, the delta T, right? Let's talk about the second block. If I write the same thing for the second block, it is M2 multiplied by S into T minus T2. And similarly, for the third block, it is equal to M3 multiplied by S multiplied by T minus T3, right? So the heat exchanged by the block 1, 2, 3 has been put to you. We have still not used the fact that there is no heat loss to the surrounding. So whatever heat exchange took place between these two, right? So heat from this went to the middleman and the coldest. The heat from the middleman went to the coldest, obviously to the lower temperature. Can we say that this particular expression, right, is demonstrative of the fact that there is a heat transfer whenever there is a difference in temperature between the bodies which are in contact with each other now? Okay, now let me come to the hint part of it, the crux of this question. In this whole system, we did not lose any energy. Yes, the energy was gained, lost, okay, by different blocks. But did the system actually gain some outside energy from the surrounding? No. Did the system lose its energy to the surrounding? No, it did not. And therefore, the law of conservation of energy says Q1 plus Q2 plus Q3 is going to be 0. So let's write it, right? So Q1 plus Q2 plus Q3 is equal to 0. The energy was neither gained by the system nor lost by the system. The energy was between these three blocks, block 1, block 2, block 3. They had the energy flowing between them. It never went out. Question says that, right? So the hint, the hidden phrase was law of conservation of energy. So this particular phrase, there is no loss of energy to surrounding, is actually law of conservation of energy, which is what I've applied now, right? If I substitute the values of M1 S T minus T1 plus M2 S T minus T2 plus M3 into S into T minus T3 is equal to 0. Now specific heat is same for all of them, right? So what is that you can do? You can take S out of this and you will get M₁T minus M₁T₁ plus M₂T minus M₂T₂ plus M₃T minus M₃T3 is equal to 0, right? So I'm going to do one thing. I'm going to take these negative values to the other side, okay? So I get M1 plus M2 plus M₃T is equal to M₁T₁ plus M₂T₂ plus M₃T3, right? So T comes out to be M₁T₁ plus M₂T₂ plus M₃T3 upon M1 plus M2 plus M3, right? There is no S specific heat which is coming in the answer. If you notice the expression number D, okay, if you solve it dimensionally also, it is wrong because it has S on the top, right? In the denominator you have mass, in the numerator you have mass and time and specific heat. S is extra. So although this may give you an impression, choice number D, that it is a correct choice, it is not dimensionally right? You could have eliminated this anyway, right? This looks too good to be true. The average T1 plus T2, the temperature, right? Without worrying about the principle of conservation of energy, calorimetry, just straight away average of these. This is no joke, right? This is physics. So this cannot be the right one. If you notice, this is the closest you could get between B and C, right? B and C were the two real contenders as far as the answer goes. So now you know the answer, right? The answer is the choice number B. So remember, whenever you see the questions in NEET examination or JEE examination or whatever exam you give, if the bodies are coming close to each other, there is no loss of energy to the system. Just remember that they're talking about principle of conservation of energy. Q, yes, you will have Qs flowing, right? Multiple Q1, Q2, Q3, these which we discussed. But the net result is what? Even if the heat flows, it flows within an isolated system. And therefore, if you see this, an isolated system will not allow the heat to come in, and an isolated system will not allow the heat to leave it. I hope this made sense to you. On this video, we have 3,000 videos, live classes recorded, 2,000 multiple choice questions for you to practice absolutely free of cost. And don't forget to put your doubts and comments, likes, etc. in the comment box. I will really appreciate if you can, if you have a doubt, you want to ask it on this question or any other question, I'll be happy to answer it. Thank you very much and wait for my next video.